StatMan! StatMan! So we're going to see whether or not these numbers, 33, 21, 20, and 26, are far off away from that expected number of results in each of those sections. And to do that, we're going to follow one of the formulas on the exam, which is for the chi-squared value. And the chi-squared value is given to you on the bottom of one of the formula sheets. The chi-squared is the sum of all the observed minus the expected squared divided by the expected. And to do that, we can just make a simple table up that actually captures what's actually happening. So we can make two columns. We can make a column for the observed. We got 33, 21, 20, and 26. The expectation was that we were going to get 25 in each area. Of course, we were off, but were we off by all that much? I mean, just by random chance, we're going to end up with something that's probably different than 25. But are these results so far off where we could consider that to be maybe where the spinner's been tampered with? So you can easily calculate the observed minus the expected, make it very clear to the person who's grading this what you're doing. So the observed minus the expected would be 8, negative 4, negative 5, and 1. And then we're going to take those answers and square them and divide them by E. So when you do that, you get 8 squared, which is 64, divided by 25. You get 16 divided by 25, 25 divided by 25, and 1 divided by 25. And each of these numbers here represents the contribution that these observations have made to the entire chi-squared value. When you add those all together, you'll end up getting your chi-squared value, which ends up being 4.24. We need to turn this value, which is like a standard deviation, we need to turn that into a p-value. And before we studied chi-squared curves, we did that with normal curves, and we did that with t-curves. Here we're going to construct a chi-square curve, and for this particular model, if we use a degree of freedom equaling to 1 less than the number of columns that we have, so we had 4 different categories, so the degree of freedom would be 3. We can construct a chi-squared curve with a degree of freedom of 3. Which looks like that. So this is chi-squared with a degree of freedom equaling 3. And a mark of 4.24 would go right there as our chi-squared value. This would be 0. Chi-squared curves are skewed to the right, and the shading always goes to the right. So the p-value would end up being just this section right here, which you could get by using a calculator command on your calculator, as some of you have as a Texas Instrument, be chi-squared equaling, I had to make sure that I was still on the screen. Chi-squared CDF would be the command, and then you could just type in from 4.24 to 1,000 and using a degree of freedom of 3. And I fit that all in? Yes, I did. So you end up finding that the p-value ends up being pretty common, actually, about 24%. And then we're on to the last step. So with the p being 0.24, you finish things off by saying, in your fourth step of your hypothesis test, you can conclude by saying that since the p-value is is higher than our significance level of 0.01, we can reject the ha in favor of the ho. That is, the wheel is likely to be fair. Well, I had some time, so I thought I'd show you a little bit about using the calculator to do these goodness of fit tests. And I'm using a TI-84 Plus. And on the AP exam, you're welcome to use those menus on your calculator to actually conduct the tests, as long as you're keeping track of everything that you're calculating. So writing down all the results that you have is good practice. Drawing those curves, normal curves, t-curves, chi-squared curves, that's all part of it, the communication of what you're doing. But in order to use those maneuvers, you have to make sure, on the calculator, you have to make sure that you end up writing the name of the test that you're doing or the name of the confidence interval that you are putting together. So as you can see on my calculator, under list 2 and list 3, I've got the observed and the expected values. And if you access your calculator to by pressing Stat and then slide over to Tests, you'll see the goodness of fit test showing up somewhere on the menu. So there it is right there, chi-squared for goodness of fit. And I've already got the list typed in, list 2 and 3. I'm knowing I'm using a degree of freedom of 3. And now there's two options. You could either calculate or draw. Calculate ends up giving you the same values that I calculated by hand. Okay? And you can even see the individual contributions listed here towards the entire chi-squared value of 4.24. So all of those contributions add up to make our full chi-squared. So listing all that information down on your test paper would be a good idea. You could also go back to the test. What's a nice feature too is you can also go back to the test menu, go back to goodness of fit, and choose draw instead of calculate. And that gives you, well, I have a leftover box and whisker graph from my last example, but it ends up giving you the chi-squared curve. It shows you the p-value and also the chi-squared value. All right, so that's it for the review for the take-home. So good luck to you in studying, and just keep on pressing really hard because I know the exam is coming around the corner early May. So get ready.